Hello everybody and welcome to our first lesson in Unit 8 on statistics. Today's topic is arithmetic sequences and series, and our objective for the day is we will investigate and apply the properties of arithmetic sequences and series to solve problems, including writing the first n terms, finding the nth term, and evaluating summation formulas. So then, what is an arithmetic sequence? In an arithmetic sequence, the difference between consecutive terms is a constant. And we call this the common difference, and we denote it usually by the letter D. In arithmetic sequences and series, there's a whole bunch of notations that we need to be aware of and use. First of all, this Greek letter here that looks like a tipped over M is called sigma. It's actually the capital sigma, and it means sum. We use it usually when we take the sum of a whole bunch of terms, and you may remember this from standard deviation and variance in Algebra 1, where it also shows up in their formula. Then D is the common difference. We just met that one. A sub n is used to denote the nth term of a sequence, and then A sub 1 is obviously the first term of that sequence. And when we take the sum of all those elements, then we call that S sub n. That would be the sum of n terms in the series, and n just tells us the number of terms that we're dealing with. So how can we tell if a sequence is arithmetic? We need to look at the numbers in the sequence and see what happens from one number to the other. In our example number 1 here, we see 4, and to get from 4 to 7 we add 3. Then from 7 to 10 we add 3 again. 10 to 13 add 3. 13 to 16 add 3. So we're adding the same number. That is the difference between each of these elements, and it's the common difference. This is 3. So yes, this is an arithmetic sequence. Let's look at the next example. From 3 to 6 we're adding 3. From 6 to 12 we're adding 6. From 12 to 24 we're adding 12. 24 to 48 adding 24. This is not an arithmetic sequence because there is no common difference. You can see a pattern here too, I'm sure, and we will talk about that type of pattern in our next lesson, but this is not an arithmetic sequence. Going to example 3. From 22 to 17, what happens? We are subtracting 5. 17 to 12, subtracting 5 again. 12 to 7, subtracting 5, and subtracting 5 again to get to 2. So we are subtracting a constant number. We are actually, in a way, adding negative 5. So our common difference is negative 5, and this is an arithmetic sequence. And our last example, from 1 to 2, plus 1, 2 to 4, plus 2, 4 to 7, plus 3, 7 to 11, plus 4. Again, you can see some type of pattern here for sure, but the difference is not a constant, so this is again no arithmetic sequence. So the way we find out if a sequence is an arithmetic sequence is by making sure that the difference between each two consecutive elements is a constant, is the same number. If we have an arithmetic sequence, we can write a rule that gives us all the elements of that sequence. And this is the formula to find the nth term of an arithmetic sequence. A sub n is equal to a sub 1 plus d times n minus 1. So we need the first term and we need the common difference in order to figure out any term we want, and that term is going to be numbered and denoted by the letter n. Let's look at this example. Find the nth term given a term and the common difference. D is equal to negative 2 and a sub 1 is equal to 2. So a sub n is equal to 2 plus negative 2 times n minus 1. Or simply a sub n is equal to 2 minus 2 times n minus 1. And that's the rule that we can use. That works perfectly fine. Now, of course, you could go ahead and also distribute your 2. And you could write a sub n is equal to 2 minus 2n plus 2. And then combine your like terms, 4 minus 2n. Both of these are perfectly fine. And when you then plug in any number for n, you can calculate the nth term of that sequence. In our next example, we're supposed to write the rule for the nth term and find a sub 15. We do have our first term, that is a sub 1, but we do now need to figure out what is our common difference between each consecutive terms. From 19 to 23 is plus 4, 23 to 27 plus 4, and again and again. So the common difference d is equal to 4. That means we can write our rule a sub n is equal to a sub 1, which is 19, plus the common difference times n minus 1. And again, if you want, just go and distribute your 4, and you get a sub n is equal to 19 plus 4n minus 4, or simply a sub n is equal to 15 plus 4n. This is the rule that allows us to find any term in that sequence. And now our second task was to find a sub 15. So n is 15. Now let's plug in 15 for n. A sub 15 is 15 plus 4 times 15, 15 plus 60, or a 15 is equal to 75, and that's our answer. And of course, you would get the same answer if you had started off with this formula here on top. And here it is. And whether you distribute your parentheses first and then use your formula with your parentheses distributed, you get one step less to do, or you do that afterwards and you do one step more afterwards, but one step less before. Same difference, same answer. We may also be asked to write the rule for the nth term given two terms only. And here our situation is we don't know what a sub 1 is, and we don't know what d is. And we need both these terms in our rule, so we have to find them. And here's the easiest way to find d. Think about the two terms that you have been given. A sub 4 is equal to 18. A sub 10 is equal to 48. So we can say that from the 4th term to the 10th term, we had to go 6 steps. We went 6 terms forward. And in that distance, the terms increased from 18 to 48. So in a way, it's very similar to what we used to do when we found the slope of a line. We can think of these as two ordered pairs, and we use these two ordered pairs to find our slope, which is the same as our common difference. And now let's set up our slope formula: y2 minus y1 over x2 minus x1. We get 48 minus 18 over 10 minus 4. We already said it's 6 steps, and in those 6 steps we increase the value by 30. That means each step we increase the value by 5. The common difference d is equal to 5. Now we still need to find our a sub 1, And we can do that by using the formula for our rule. A sub n is equal to a sub 1 plus d times n minus 1. And we're using one of those two terms to plug in for a sub n and n. And then we solve the equation for a sub 1. If I use a sub 4, that's 18. I know that the fourth value is 18. So 18 is equal to a sub 1 plus 5 times 4 minus 1. 18 is equal to a sub 1 plus 5 times 3. 18 is equal to a sub 1 plus 15. Subtract 15 from both sides. And 3 is equal to a sub 1. Now we got our a sub 1, we got our d, and now we can finally write our rule. A sub n is equal to 3 plus 5 times n minus 1. Now, let's see if that works. Can we get a sub 10 that way? A sub 10 is equal to 3 plus 5 times 10 minus 1, which is equal to 3 plus 5 times 9. A sub 10 is equal to 3 plus 45. And a sub 10 is equal to 48. One look, yes, checks out. We can also figure out which term a specific number is in a given sequence. In this example, determine which term is 57 in the sequence that starts negative 59 and so on. So 57 is a sub n, but we're supposed to find out what is n. We don't know what n is. Let's see, what do we have? The sequence starts with negative 59, so this is a sub 1. And looking at the numbers, they change by adding 4 each time. So d is equal to positive 4. So that allows us to set up our rule. Our rule is a sub n is equal to a sub 1 plus d times n minus 1. Let's plug in what we have. We have a sub n, which is 57, and that's equal to negative 59 plus 4 times n minus 1. Now we're solving this for n. First of all, let's get rid of the parentheses. 57 is equal to negative 59 plus 4n minus 4. 57 is equal to negative 63 plus 4n. Now I'm adding 63 to both sides. 120 is equal to 4n. Divide both sides by 4. And 30 is equal to n. So we now know that a sub 30 is the term that will give us the value 57. Alright, you guys, so much for this. Now go ahead, watch the second part of this tutorial on arithmetic series.